Today we're going to be building congruent triangles. What I'd like you to do is take a few minutes, and you should have had a few minutes to write down what you know about isosceles, equilateral, and scalene triangles. So hopefully you wrote something like isosceles, two congruent sides, two congruent angles. And you should have drawn something like that, something with two. Equilateral, you should have said something about all sides and angles congruent. And hopefully you drew something like this, or maybe you drew a large one where they're all sides. And scalene, all sides and angles different. Remember, equal, all equal. Scale, when we get all get on the scale, we weigh something different. So you might have had a short, a medium, and a long. A little, a medium, and a long. Okay, now I'm going to give you a few minutes to write down what you know on page 10. To write down what you know about right, acute, and obtuse. Okay, so you should know that a right triangle has one right angle. An acute triangle has all angles less than 90 degrees. And an obtuse has one angle more than 90 degrees. Okay, so when we look, that was just a review because we need those. When we look at the next page, if we were in school, I would have given each of you a pack of Exploragons. And Exploragons are just little pieces of sticks that look like this. If we all had gotten a blue, an orange, a purple, and a yellow, and we connected them, it doesn't matter how we make this or which way we turn it. And you can see on yours, and I'm going to label yours if you want. So you can see right now they don't look the same, but if I turned it over, they would be the same. Okay? But they're still the same triangle. The triangle might be turned, the triangle might be moved down, the triangle might be flipped over. But right now, they're all the exact same. This right here is an example of a scalene triangle. It has a short side, a medium side, and a long side. Okay? And it could be right, it may not be. It's either right or acute, because there's no way this is obtuse. But we know for sure it's scalene. So we would all build the exact same triangle. This is called the side, side, side triangle congruence theorem. And what it basically says is, and this stands for side, side, side. And it says, if all three sides of one triangle are congruent to another triangle, the two triangles are congruent. So like the one on the paper right here And this one must be congruent. Okay, giving you a chance to write down that rule. This is called the side, side, side. And you can just write side, side, side. You'll see in a little while. When you're ready, turn the page. Okay, we are looking at page 13. So here's an example of two triangles. Okay, it says write all the congruent statements. So here's what we know. We know this has a 1 and this has a 1. So I know that side AB is congruent to side DE. Or is it ED? That's what you have to figure out. I went with A, and that was on the side of 2. So I know D should have come first because that was on the side of 2. So that is the same as DE. Again, 1, 1, and I know A was on the side of 2 and D was on the side of 2. Now I'm going to go to AC. AC is congruent. That has a 2, so I have to do this 2 to DF. And my final one is going to be BC is congruent, BC side 3, EF side here, okay? And B was close to 1 and so is E, so EF. Notice I'm lining up the letters that are the same. That's important to the reader. So if all of those are congruent, then I know that triangle ABC is congruent to, again, A went with D, B went with E. Okay, let's go to the next one and prove it. What we're doing is called a proof. We're going to prove what we know using side, side, side. We need three things. We need a side, and a side. And here's what this is called, the given. So our first thing, we're going to make it into a 2-column proof. Okay. All right. So we know that A is midpoint of JN. That's called the given. Okay. We also know that J is congruent, that JK is the exact same size as NK. How do I know it? It's given in my picture. So I already have one S. We also know that these two must be equal. JA is congruent to NA. JA is congruent to NA. And I know that because this is in the middle. It wasn't given, but I knew it because A was in the middle. That's called definition of midpoint. Since A is in the middle, I know these are equal. So now a really good strategy that I try to do is to prove, when I'm trying to prove the triangles are the same, I might highlight, I'm trying to prove that this one is equal to, I'm just looking for another highlighter, but I'll do it in this color. This one. So far, I've got this side and this side. I've got this side and this side. Now, I also know that AK is the same as AK. So there's my last side, 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 side. I know that because it's the exact same. That's called the reflexive property. It's like when you look in the mirror and you see the exact same thing, you see yourself, that's what's happening here. It's called the reflexive property. So now I've got side, side, side. So I know that triangle JAK is congruent to triangle NAK because of side, side, side. These are my reasons. Okay, let's turn the page. Okay, so we're going to try this again. We're going to make a proof here. And these are our reasons. So given the information provided, we're trying to do side, side, side. So that's what we're trying to look for. And we know this is a rectangle. There's my given, that it's a rectangle. JKML is rectangle. That's my given. That's step one. Okay? Well, what do we know about rectangles? We know that those two sides are congruent. JM is congruent to, and I'm going to go J, and I'm going to do L. Notice, because J is a right angle, I look for the right angle. LK. And how do I know that? That's definition of a rectangle. There's one side. There's an S. We also know these two are congruent. Here's our step 3, that JK is congruent to LM. Right acute. Also because it's a rectangle. And my second to last step is I need the other S. There it is, MK is congruent to MK. And I know that because it's the same thing. That's called reflexive property. There's a new word for you all. And now I know. Step 5 will be that triangle KJKM. I chose to do that way. J, it could have done a different way. Is congruent to triangle. What went with J? L, K. This was little. I need the little. M, K. And we know because of side, side, side. Okay, last one for today. So again, here's what we know. We know that M is midpoint of HP. That was my given. There's my step 1. And I'm trying to prove that these two triangles are equal. Okay, let's see if I can do it. I know that M is in the middle of HP. If M's in the middle of HP, this equals this. HM is congruent to PM. Definition of midpoint. Do we know these are equal? They might look it, but it doesn't say it. Do we know that M is in the middle of these? Doesn't say it. So this one is not enough info. We can only prove one side. So this one doesn't work.